Hi everybody, in this video I told us we were going to go ahead and go through this proof, but also let's remind ourselves how to go ahead and solve for scale factor. Okay, so starting off with our scale factor, we have our proportions, right? We talked about our proportions in terms of corresponding parts. So if we're looking at our corresponding parts, our side lengths, I'm going to use my new lengths of my triangle divided by the original lengths of my triangle. So that's how you would find your scale factor. Okay, noting that sometimes if we went from big to small, you're going to expect a scale factor of less than 1 or a fraction. Okay, it's only when you're going from small to big that you are going to be having a larger scale factor. Remembering also that scale factor is always a multiplication, is always multiplication. All right, so let's get into this. We're going to go ahead and mark up, we'll leave all of the markings for what our givens are. So we have that SP, so this piece right here is 4. We are told that PR, so this piece, P to R, is 12. Then SQ is 5, and Q to T is 15. Now we are trying to prove that the triangle RST, this big triangle, is similar to my small triangle PSQ. So let's also go ahead and redraw my triangles out on the side here. RST, obviously I'm not drawing it to scale. PSQ. Okay, so I'm going to go ahead and also rewrite the things that I know. I know that PS was 4. I know that SQ was 5. Now let's take a closer look at these side lengths for RS. Note that RS goes from here all the way to here. So that means I have 12 and 4 together, making a full length of 16. And T to S goes from 15 and 5, give me a full length of 20. Okay, so making sure that we don't get tricked there because they gave us pieces of our lengths. All right, let's get into our proof. So our statements, and then we have reasons. Again, always starting with our givens. So we have the given of SP is equal to 4. We have that PR is equal to 12. That SQ was equal to 5. And QT is equal to 15. These are givens. Okay. From here, I also use this information to tell me about the side lengths of my larger triangle RS and ST. I'm going to put that in one line because it does fall under one reason. So RS is equal to 16 and ST is equal to 20. This both fall under our segment addition. Okay, so segment addition, because I took this segment of PR, 12, and I added it to PS, because I know that those two segments together will give me the full length of RS. Same thing with QT and SQ, giving me the full length of ST. Okay. Now, something that I've noticed is that if I am corresponding my PS side to my RS side, let's take a look at what we can do with proportionality, if we have any. So again, I went from the big triangle to the small triangle, meaning my small is my new. So let's use PS over RS, which is 4 over 16. And then I'm going to use SQ over ST, which is 5 over 20. Let's check if these proportions are the same. If I have 4 over 16, that reduces to 1/4. 5 over 20 also reduces to 1/4. So I do have a scale factor of 4 because I have this proportionality, PS over RS is equal to SQ over ST. Oops, and not 4, 1/4. So we do have proportionality, okay? Next step, I have two sides that are proportional. I don't know about the third side, but in terms of the similarity statements that I know, I do have an SAS possibly. And that is because note how these two triangles do lie on top of each other. This angle S is always going to be equal to itself by our reflexive property. Therefore, I'm seeing a proportional side, congruent angle, and another proportional side, allowing me to state that the triangle RST is similar to triangle PSQ by SAS similarity. And that's how you worked out that proof.